summary.
Okay, and I think all right, good evening, everyone. Welcome to Trolling World Logic for the 29th of August, 2015, and we're here 7 p.m. here, UK time, 2 p.m. Eastern Standard Time over stateside. Just to let everyone know, you can call in in the show later on. The Skype contact, as you see, is the bottom of your screen, is Trolling World Logic. So just add us on Skype. I'll send a few PMs just to check what the topic of your question is, and we'll add you in due course. Just please do not call us. Just distract us during the interview or the show. And so we'll just quickly introduce the panel tonight, and welcoming back Pumpkin. What's happening?
Not much. Home from work, looking forward to going out and getting drunk, but in the meantime, I'll settle for this.
And welcoming back Marty. How's it going?
Yeah, I'm doing fine.
And Zilla, what's up?
All good, all good.
Okay, everyone. Kitch was meant to be here, and he did have a nice introduction written for our guest. So I am just going to have to come up with hopefully something workable on the fly. Welcoming to the show is a well-known biotechnologist. He was involved in understanding expressions of Bt genes within cotton, and I can't remember your exact role, but I'll say that you do work within Monsanto. So everyone, please welcome to the show, Dr. Fred Perlak.
Thank you very much for having me, Cal. It's a pleasure to be here.
Oh, it's great to have you. And so I think we'll just get on with a few basic questions just to get your background and all that. So what got you interested in biotech?
Well, I had a bachelor's degree in science from Fairfield University in Connecticut. And I did a senior project working in microbiology as a senior project, and I found that I really enjoyed working in the laboratory more than anything else that I could do. Went to graduate school, worked on Bacillus thuringiensis and its genetics as a graduate student. Found I had an aptitude for doing research. It was easy for me. Time went by very quickly, and from there I did a postdoc at the Ohio State University in Columbus, Ohio, and then from there to Monsanto. When I started at Monsanto in 1981, my job was basically to identify how we could take advances in recombinant DNA, genetic engineering, and apply them to improve agriculture. And so the obvious choice was to move Bt genes both into other bacteria that colonize plants and eventually put Bt genes into plants.
Okay,
and for those of us who are not sciencing regarding squishy stuff, what's a Bt gene?
Bt stands for Bacillus thuringiensis. It's a microorganism found in the soil. It has the unusual characteristic of producing a protein as a distinct crystal inside the cell. That particular protein has very high toxicity to a certain class of damaging insect pests, the lepidopteran insects. Those are the insects that are the larval forms of certain moths that are particularly devastating to crops. Corn earworm, tomato fruit worm, cotton bollworm. If you see a worm on a tomato or ear of corn or even on vegetable crops like lettuce or cabbage, it's probably that group of insects. And Bacillus thuringiensis, the protein produced, is extremely active. In fact, for years in the 50s and 60s, farmers have been can utilize microbial preparations of Bacillus thuringiensis sprayed over their fields to protect them from damage by insects.
Okay. All right. So Zilla or Pumpkin, do you have anything to come in with right now?
One little question is, I've always been curious about insect repellent GMOs, and the same could be said of pesticides, but I've always been curious. The fact that insects can't really eat them, does that expect or does that cause any kind of damage to the food chain with, less food for something one step above insects not being able to get it and causing a knock-on effect? Does that ever become an issue, or?
That's a real good question, Pumpkin. I have to tell you, it's very difficult for me to call you Pumpkin, but that's another story.
Call me angry. Everyone does.
Okay, angry. That's good. Because one of the things we have to assess when we look at plants that are genetically engineered is what effect will they have on the environment? How will they affect things that happen? In the case of BT plants, the insects that are eating the plants are described as pests already. There's nothing natural about the fact that you have a large number of acreage of those particular plants, and the insects get to very, very high, unusually inflated numbers because it's such a fertile area for them for having food that they can use. So it really isn't as disruptive as you might think. There is a ecological balance that you find in a field that can get changed or established. So, for example, in the United States, in Arizona, they had problems with an insect called the pink bollworm, and they also had problems with whiteflies. The way it worked was they would spray over and over with pyrethroids to try to control the pink bollworm. As a consequence, they were killing the whiteflies, but eventually the whiteflies were becoming resistant, and every time you sprayed with pyrethroids, more and more resistant whiteflies would show up. As a consequence of using all those insecticides, you actually caused a bloom of the secondary pests because you were killing all the predators of the whiteflies more efficiently than you were killing the whiteflies. Once BT cotton was introduced, we controlled the pink bollworm. When the pink bollworm was controlled, they no longer sprayed the pyrethroids. When they no longer sprayed the pyrethroids, the natural predators took over and controlled the whiteflies to a manageable level in the field. So by eliminating one of the biggest problems in having to spray constantly for it, you actually got a halo effect where other pests were more efficiently controlled by natural mechanisms.
So it's almost sort of like a chicken and egg situation.
It is.
Yeah, there's so many insects because there's so many crops, and
well, and if you're a farmer, there are certain treatments that you make. So on a big field, for example, a farmer might spray a pyrethroid, but he'll know he'll have to go back and spray 21, 28 days later for another pest that'll bloom as a consequence of that spray. The advantage of things like BT cotton as an example, is if it's skillfully used to integrate into a program, a farmer can then maximize the use of of beneficial insects in an integrated pest management system. It's a tool. Biotech is a tool, and if properly used, is very, very effective. But just because you can cut lumber doesn't mean you can build a house. You have to pay attention. You have to work at it. And if you're good farmers, do well with these kinds of situations.
So it's, if I'm understanding it right, it's basically using BT. Is it BT resistant or BT infused?
It's BT infused. We actually produce the protein that used to be produced or still produced in the bacteria, but we take that gene out and we put it specifically into the plant so it produces it throughout the plant.
Right.
So that when the insect shows up, it's as if you had sprayed it with BT right when he gets there.
So it's by using the BT infused plants, it's reducing pesticides. So it's sort of a more efficient method of pest control rather than try to solve one, having to solve another. So it's
that's correct. The pesticides that traditionally are used, organophosphates, pyrethroids, carbamates, these classes of pesticides are fairly nonspecific, whereas the BT protein is highly specific. It's specific against these lepidopteran insects doesn't affect earthworms, doesn't affect honeybees, doesn't affect other pests like whiteflies or aphids or thrips. But it takes out the biggest issue a farmer might have in his field, which allows him to be more selective and more judicious on how he treats those other insects.
Yeah. And that's actually answered another one of my questions when you said it doesn't affect bees, because I was going to ask if it would have any kind of effect with bees wanting to take the nectar and pollinate other plants, but
now, the beauty of BT, there's two really highly desirable characteristics about this protein. First and foremost, it has a high degree of toxicity against the target host, among the most potent proteins for the insect toxicity. Secondly, it's extremely specific. Think of the BT protein as a key, and the insect has a lock. The key fits very precisely into the lock, and only the insects that have the right lock does the key fit. And that's the lepidopteran insects. Other insects, other organisms, like even invertebrates, earthworms, other insects found in the soil, humans, animals, they don't have the right lock, so the key doesn't fit, so it doesn't work. It's one of the marvels of nature.
Okay, I'm sorry for butting in here. We have a guy in the chat room, and he's bringing up some. It's probably an anti-GMO guy, but he does bring up something interesting. I want to hear what you have to say about it.
Sure.
You have to buy seeds every year, presumably, if you're planting the genetically modified stuff. You have to buy seeds every year, as they don't reproduce like natural seeds do.
can I
I think he's basically hinting that it's a way to get farmers to cough up money or something.
if I would be able to say, as
Yes.
I live in a farming background, you always have to buy seeds every year, because you're never going to have enough seeds from the previous crop, because you're harvesting the seeds with the plant. So
Well, there's two parts, Marty, that come up from this chat room, and one of them is a big misconception, and that is somehow the seeds are changed so that they don't germinate in the subsequent year. This is all part of a urban myth that came out of a technology that was originally patented by a seed company Monsanto eventually acquired, Delta and Pine. It's called Terminator technology, and it was a very clever but very complex proposal for how to keep seeds from germinating from one year to another unless you intervened. The reality is it never got off the ground. It never made it. That myth persists for the last 20 years, but if you look up their patent, they abandoned their patent. They never filed any reduction to practice. There's never been any data, but the myth persists that somehow this is true, that we've somehow changed the seeds. Now, the other aspect is you have to look at the specifics of individual crops. So, for example, corn is grown as a hybrid. It's been grown as a hybrid since the late 1920s, early 1930s. No one saves corn seed in the United States or in Europe, maybe in a few places in Africa and Asia, but it's grown as a hybrid. And the hybrid is where two parents come together to produce a hybrid seed that has increased vigor and characteristics just for that one generation. If you keep the seed for the next generation, those characteristics will segregate away. A lot of vegetable crops are hybrids, and they convey a certain amount of vigor that is better than either parent individually. So in the case of corn, no one saves seed anyway. In the case of cotton and soybean, which are also GMOs, those are open pollinated varieties, and theoretically you could keep the seed in subsequent generations. Now in the US and many other countries, farmers sign an agreement that say they will not do it. They will not keep their seed from generation to generation. Many farmers who are hoping to make money on their crop don't save the seed anyway. Saving seed, you accumulate diseases, problems, quality characteristics, germination. If you're a farmer with a lot at stake, you want to buy new seed every year because the germination rates are higher and you have an assurance of quality. And you also
you're getting rid of, you're ensuring that you get rid of genetic defects and stuff like that's basically the point. Is that it?
Not so much genetic defects, but just growing your crop in the field, you end up picking up diseases. Plants get sick all the time.
Yeah.
And if you're not fastidious about the way you saved your seed, you could pick up some fungal diseases that carry on your disease or viral diseases. Buying certified seed means that the seed has been inspected, it's been grown under more stringent conditions to ensure that the seed doesn't carry those deficiencies. Plus, every year there are new varieties of seed that give you better and better yield. So if you keep your seed for 3 or 4 years and your neighbor is buying new seed where he gets a couple bushels more per acre per year, after 4 or 5 years, you're 10 bushels behind. You can't afford that.
Yeah.
And if, considering my country's background with the potato famine, it was all because it was all essentially the same strain of potatoes, and it just took that one disease to hit one batch, and that was it. Almost the entire country was wiped out because it affected all of the crops, because essentially there was no hybrids. They weren't mixing one type with another to protect against a specific strain.
Right. And one of the concerns people have is biodiversity or diversity of crops in the field. And people talk about the potato famine as an example. And in 1970, there was a rust, a viral disease that went through corn plants. Actually, it's not a viral disease, it's a fungal disease, a rust. It went through a whole 25% of the corn crop was eliminated through the disease. There is a lot of diversity because there is a lot of competition among seed companies. For example, Monsanto sells a little over 500 different kinds of corn on a global basis every year.
So we can hear you typing.
Oh, that's me. Sorry, I thought I muted.
Yeah.
Yeah, I was going to say I'm muted.
Sorry, pumpkin. I meant
carry on.
Force of habit.
Anyway, we produce 500 different kinds of hybrids a year. On an average, we probably replace about 100 of those. And we introduce new disease resistances and varieties that have different characteristics. And it's a very competitive field. As a consequence, the biodiversity is stronger than it ever has been before, because there is a lot of research going into it. In the past, when things were more static in the seed industry, there wasn't the incentive to invest in new technologies and new varieties. Now there's a lot of competition, and that's good for farmers. And it's because farmers buy seed every year because of these traits.
Yep. We'll go. There was a question from the chat room that related to an earlier topic, so we'll jump back. Zilla, you've got the question queued up.
Yeah, it was from Microbloganism in the chat room. Wanted to know, is the BT gene in GM crops identical to the gene in B. deoxygenesis?
Yes. Now, since we first put the first gene in, there are a number of different ones that have had changes. The very earliest ones were identical. I think there was one amino acid out of 1,179 that were different. And that was just the second amino acid. It's a minor characteristic. But it was essentially the same. And in fact, in order to be able to commercialize it, we had to show that it had exactly the same specificity, exactly the same activity, both against target and non-target pests. which involve doing activities and feeding studies for earthworms and honeybees. And I don't even know how you get earthworms to eat the protein, but that's another story. But honeybees, earthworms, all sorts of feeding studies with birds and quail and rats, just to show that it's exactly the same. Now, since then, there's understanding of the specifics of how the Bt protein actually works, and there's mixes and matches to improve activity through molecular engineering. In other words, we understand the 3D structure, we understand where the receptors are, we understand how it interacts with the organism, and we can make slight tweaks. Think of it as improving the original pharmaceutical of penicillin with derivatives that are more active. That is actually a wonder of science, and it's unbelievable how sophisticated all that work has gotten, but it is very precise. And the requirement is always to show that it still retains the degree of specificity that it previously had. In other words, still working on your target pest, but not expanding it beyond to insects that you didn't want to control or organisms that would not benefit from the presence of the protein.
Okay, and I'll take this opportunity to hopefully welcome Kitch. Are you there?
Yes. How's my audio?
Absolutely perfect.
It's
Terrible.
actually good for once.
Remarkably perfect, actually.
Scarily
What
perfect.
happened?
Let's not jinx it just yet.
All right. This will be a good chance, Kitch. You've just come in, so I know you've got a heap of questions for Fred because you work in a similar field, so have at it.
Yeah, sure. I don't know what's been asked, so if I ask something that's been asked, just let me know. I know that you've worked in Hawaii. What was that like to do science in such a beautiful state?
Well, the job I had in Hawaii was heading up our overall seed operations in Hawaii. Hawaii is a beautiful place. And we utilize Hawaii as a nursery. There's really not much research there as so much as it is a nursery for corn. Now, we employed almost 1,000 people in Hawaii, very hardworking, wonderful group of people. I enjoyed my time there. But in our nurseries in Hawaii, we grew corn 10 feet at a time. It's called a short row equivalent. It's 10 to 15 plants per row, 25 square feet, and we do over 2 million of those on an annual basis. So 2 million 10-foot rows on fields all over the island of Hawaii. We keep track of each of those rows. The idea as a nursery was that we were trying to move the genetics in a specific way. Generating a new variety is like turning Rubik's Cube. You have to get all the panels to line up. And no matter how skilled you are, you still have to turn the panels a certain number of times. In Hawaii, all we did was turn panels. All we did was do crosses, set the genetics, collect the seed, plant the seed, send the seed off, get it analyzed. We did very little analysis per se. We were more about rearranging the genetics to have the plants look the way we know we wanted them to look. Plant breeding nowadays is such a scientific process. I am amazed and absolute in awe of how much we know about what we want out of a corn plant, a soybean plant, a cotton plant, what it should look like on a molecular basis. And that's the big change over the last 10 to 15 years. It is a true triumph of science. Absolutely amazing. I loved working in Hawaii. The people there were just wonderful. And it is a gorgeous place to be. I also know how to make really good Mai Tais now.
I think me and you will have a discussion about that later.
Good.
So,
Okay, I'd like to ask about this. The guy in the chat room keeps going, but I think he's asking questions that need to be brought up now that we have someone who can actually respond to them. He started talking about nutrition in GMOs, that there's basically if it's genetically modified, it has no nutrition in it. Obviously, that's wrong, but I'd like to hear exactly, where does this come from? What is... I'll just put it like this instead. What is the point of modifying anything? If you can just dumb it down to like the intelligence level of a 5-year-old.
Wow, you're being generous.
Yeah, I'm being generous here.
I got it.
Why modify anything?
Well, the why is so that you can increase the genetic capability to provide traits or characteristics that improve the production of that particular crop. Putting a Bt gene into corn makes it resistant to certain insect pests, so you spray fewer insecticides, which is more sustainable in the long run. Now, the misconception about genetically engineered crops is that they are somehow massively changed from what you ordinarily see. But if I were to show you a GMO corn plant next to a non-GMO corn plant, they would look identical to the naked eye. So think about it this way. If you have a library of books, say 50,000 books, the genetic capacity for corn is about 50,000 genes. So think of the DNA of corn as 50,000 books on a shelf. Each book is a gene, a distinct beginning, middle, and end. Each gene tells a story. Each gene has a function. What we do when we genetically engineer the plants is we take one more book, just one more book, and put it on the shelf. We know exactly where we put it in a very precise way. We make sure it doesn't interfere with all the other books. We make sure it is in a place where it can be read, where it can be understood, and that it doesn't disrupt the rest of the plant. So when we're putting that one gene in, we'll generate 10,000 plants, and we'll go through a very complex process of eliminating ones which don't look quite so good, which don't have the characteristics we want, and we'll winnow it down to a very small handful. And then we'll do tests which is called substantial equivalence. We'll grow the plant that has the gene compared to its exact parent without the gene. And they have to be identical under conditions where we analyze all the things that are coming out of it. So for instance, in corn, we look at the growth characteristics. We make sure that it still has the same growth patterns, maturity levels, that the corn that comes out has the same amount of protein, same amount of carbohydrates, same amount of oil, same amount of fiber. It has to be substantially equivalent. In other words, indistinguishable from any other plant. Our goal is to provide a trait that is so specific. A farmer, what he wants is he wants his old corn that he's used to growing, but he now wants it insect resistant. So it's exactly the same. And if it wasn't, it wouldn't be good enough. So in terms of nutrition, there are no nutritional differences. It is substantially equivalent. And if it wasn't, we wouldn't be able to bring it forward. If it wasn't, it would have
because
to
people
be
wouldn't buy it if nothing else.
Well, it would have to be labeled differently if it wasn't the same.
Yeah.
I
Go ahead, Pumpkin.
trying to think of a way to word this. It's something I'm somewhat curious about because dealing with the person in the chat who completely ignored what you were saying, it slightly irritated me. Whenever you're doing shows like this or you're having any kind of debate or discussion, do you ever find it grates on you when people demand evidence or make these assumptions and promote urban myths about GMOs, ignore it? Because there's one in the chat that I saw that made me almost punch my screen in anger, which was that you're putting AIDS in plants, apparently. Yeah, it's one of those things. Does that ever grind you down?
You know, I can always understand people having questions about the technology. It's new and it's different. It's not what they're used to. And it's so much easier to doubt than it is to believe. Because quite frankly, when you talk to people, they'll say, well, why do we need GMO plants? I go to the supermarket and there's plenty of food. Obviously, that's not so important. Well, it is to the farmer who grows this and how he grows it and its efficiency, and it does have a big fit. I can understand reluctance. What I don't understand is people completely not wanting to listen. And if you hear something, well, okay, try to find out where this falls out. Where does the logic, if you were an investigator or a detective, where does the logic fall out? So if, for instance, the myth about Terminator genes, it continues and continues and continues. So I say, look, show me a permit where we've actually ever tested it. Show me where it doesn't work. When we brought BT cotton to India, the Indian regulatory officials required certain molecular tests to show that it wasn't there. I said, why don't you just take the seeds and plant them? And if they don't grow, give me a call. He sends me an email 3 months later. He says, they all grew. You must have done something to them. I said, then plant them again. People can find the evidence, but they have to be open to the possibilities. It's just one of those things. You can never satisfy everyone, but you have to be able to satisfy yourself and other people who are willing to listen.
And there's another issue here, isn't it? We can provide a certain amount of food for the human population, given the farmland available. There are two ways to provide more as the population grows. One is to get more farmland. Another is to make better use of, more efficient use of the farmland that's available.
Right.
I mean, are we gonna tell people, sorry, don't have kids because we can't provide any more food? They're just gonna starve. Sorry. I mean,
Well,
we obviously have to get more food somehow.
I think if you talk to most experts in this field, they'll say that it is in our best interest to freeze current agricultural acres at their current level, and then invoke something called sustainable intensification. In other words, work on improving better use of the existing land.
Yeah.
And therefore, you will be able to produce more per acre. Because remember, if you do take more land away to go into agriculture, you're taking it away from housing, you're taking it away from recreation or conservation, other places that are important to people. Now there
Cutting
is
down rainforest. I mean, that's not good.
Well, a third way is looking at reducing the amount of waste. According to some WHO statistics I've seen, most people agree that we waste between 30 to 50% of fruits and vegetables, for example, or certain other kinds of foodstuffs. So I cringe when I hear people say, oh, I will never eat bread that has preservatives in it. And so producers then start producing bread without preservatives. Well, then you buy a loaf of bread, you eat a couple of pieces, the next day, 2 days later, it's hard as a rock and it's green. That all goes in the waste bin because you obviously can't eat it. The lack of preservatives actually exacerbates the problem that you have, which is food waste. All that food, all that grain that was produced, it made it into the bread, it was marketed, it made it to your table, and now it's in the trash bin. Now, if you can buy just what you need to eat, that's fine. But I buy sandwich bread. I make my own sandwich at work, and I look for ones with preservatives because I want it to last the week. I have this problem with wasting food because I am involved with agriculture. I know what it takes to produce this stuff, and I'm so grateful. I can't afford to waste it.
Yeah, I'm sort of guilty of wasting a lot of food myself, but on the plus side, here in Sweden, and especially in my hometown, we actually we throw food away in specific trash bins because it's being used as biofuel.
That
So
is
it's not
another.
it's not a complete waste.
That's very good. I know countries like Sweden are very progressive. My daughter lives in New York City, and they have a very aggressive program for composting and reusing foodstuffs and food waste that is quite laudable. But the best use of it, obviously, is for human consumption.
Yeah.
Okay, Zilla, you've got a question from the chat room. Then we've got a question from Pumpkin after that, and we do have a caller waiting. So Zilla, you go up first.
Cool, yeah, this one's from Bored to Bits, who I first want to ask when he's next going to bring a video out, because I'm really waiting for it.
When are you going to read the
love your stuff.
Lolcats Bible?
Yeah. And Bored to Bits asks, do the seed reserves maintain a copy of all original strains in case there is a future unforeseen negative to the gene manipulation?
There are a lot of seed banks, and to give you an idea, when we generate a new variety of corn, we do it not as a genetically engineered variety. We do it as traditional breeding, so it doesn't have GMOs in it. And then we add the traits to it later. It's not intuitive, but if you think about it, we constantly have new traits that are being upgraded and improved, and we have new varieties that are constantly being improved. So you have two parallel tracks of research going on. In our case, we generate new varieties of corn, and then when we have new traits, we cross the new traits instead of the old traits into the new varieties. So we do maintain those, and they are maintained in a lot of different ways. And then we also provide, we provide seed to people in the EU, for example, that are traditional non-GMO seeds, excuse me, of some derivatives of the varieties that we grow in the United States. So there is a reservoir of GMO and non-GMO seeds that are constantly archived and kept.
Okay.
Does that make sense?
Surprisingly, yes.
If it makes sense to
Yeah.
Pumpkin, you're doing something right.
Thank you.
All right, Pumpkin, you had a question next, and we do have a caller waiting. So, Pumpkin.
Grand. My question actually ties in fairly well with the last one. It's not so much to do with backlogging what you've done in case there's future problems, but I'm guessing that when you find a new strain and add it to the plant, it's done so in a very controlled environment. Like it's not that you're just going to start going, hey, we made new seeds, throw it to the wind.
Yeah, it is. It's a very complex process, actually. For us here at Monsanto, we have a 5-step process. It starts with discovery. There's 4 intermediate phases, which talk about proof of concept, early development, advanced development, pre-launch, and launch. So total of 6 phases, 4 internal ones. Discovery is all laboratory, all in highly controlled conditions. In order to take a new gene and put it in, we have internal review committees to be able to assess the potential dangers, issues, concerns that might happen. If we want to go out to the field, we have to apply to the United States Department of Agriculture, EPA, other organizations, and confirm for them why we want to do it, what we want to do, where the source of the gene is, what it's going to look like. And then all those studies are highly regulated. They have very strict requirements on reporting and planting and border rows and isolations and monitoring. Remember, all these things take liability, and if we were to go out with something that caused some sort of problem, even a minor one, we would be liable for it. So we take great care to make sure that what we do is well controlled and well identified. By the time we hit proof of concept and early development, we have a pretty good idea that there aren't going to be issues with safety or security or some other issues. It's more about performance, but safety for us is first and foremost. And in these processes, we look at things like, does it have potential antigenicity? Would it be an allergen? Would it be a pest if it got out? Would it interfere with other crops? Would it limit the functions or the opportunities a farmer might have? All those are considered. This is hard work, and it's very precise and very carefully done. It's very expensive. So to give you an example on the 5 different stages, when we start off in discovery, there may be 2 or 3 people working on it. By the time it hits launch, there's probably a couple of hundred on it. And that's probably a 10 or 15 year period. I'd answer your question there, Pumpkin.
Pumpkin.
It answered it spectacularly. It is genuinely heartening to hear that not only are you setting preliminary controlled states, but referring back to the seed banks, that even if something completely unforeseen happens down the line, that you're ready to step in. And the liability to have to say our ass is on the line if this goes bad.
Yep.
Genuinely good to hear.
Yep,
Okay.
it sure is.
All right, we do have a caller. Long time no see. Casey, how are you doing?
I've been doing all right.
Okay, and well, you've got some questions for Fred, so fire away.
All right. Here goes nothing. Okay. I was wondering, you know how there's endangered species of plant, like, for example, the loneliest palm all the way in the islands in the Indian Ocean. One of the islands in the Indian Ocean, essentially, this is considered the only species of palm. But however, I was thinking that, do you think that the possibility of, say, doing some
Casey,
genetic engineering, but at the same
Casey, you're breaking up
time
badly.
keeping the wild type genes, to be able to allow it to do things like have disease resistance and all.
Sorry.
That.
Sorry, Casey, you're breaking up badly. Can you try switching off your webcam and asking your question again? We couldn't make out a lot of that.
All right.
Okay, try again.
All right.
Yeah, that's
sorry
better.
for the interruption. Okay. As I was saying, I was thinking, what if like genetic engineering could be used for things like conservation of plants? Like, I'm not talking about like get rid of the wild type or anything, but like adding some disease resistance to it.
That's an interesting concept. I hadn't even thought about the improving near extinct varieties in terms of plant preservation. It gets to be a convoluted conversation, because if you genetically engineer it, then it's no longer what it used to be. I think in those cases, it's better served as trying to cross it with something that's a close relative in order to maintain or provide resistance or characteristics, or try to identify preserves or areas where you can plant it where it will survive. It is many times, at least when I've heard talk about the concern about deforestation, it's the loss of habitat in particular kinds of plants in that particular geographic area. I think conservation is a great opportunity, and that goes back to, if you have increased pressure from populations for more and more land, intensifying the amount of production you have on the existing land allows you to then set across or set aside even more and more land for conservation. When we lose a plant, some part of us all dies. Whenever we lose an animal or plant as part of our existence, some part of all of us dies along with it. And that's something that we shouldn't abuse and try to make sure that we hold on to. So I agree with you, Casey, but I don't think GMO or genetic engineering is the way to go. That's my opinion.
Okay, Casey, you had another question.
I understand.
You're breaking up again.
Yes. Going off the topic of plants, I'm not sure if you heard about it or not, but well, have you heard of the genetic engineering of things like mosquitoes and all that, and like fruit flies?
There are a number of...
Casey, your microphone's breaking up quite a bit. You may just want to
what
post it in
the
chat.
idea is to do is try to make them sterile and then like release them out into the environment.
I know they've worked on that in a number of different agencies, and sterilizing males, for example, or I don't even remember if it was males or females, so that the population would self-stabilize to a very, very low level. If you understand enough about the ecosystem, if you understand enough about the life of the insect and how it interacts with everything, yeah, okay, but those make me a little nervous. I just don't know enough. The nice thing about plants is you look at the plant and you don't like it, you just pull it up and it's gone, it's dead. It's not going to be evasive, it's not going to hide, it's not going to go to other places. Plants have roots and they're easy to mitigate problems.
Okay, is that everything, Casey?
Well, I was gonna ask like, well,
Casey, sorry, I think we'll have to leave you because sorry, Casey, can you hear me? Yeah, I'm afraid we'll have to drop you because we can't hear you at all.
Then sex and like something.
Casey,
you're gonna have to go post the question and we'll ask it for you.
Yeah, your line quality is terrible. We can't make you out at all now. Okay, sorry, but we'll have to leave you there. Yeah, thanks anyway, Casey. Sorry about the connection problems. And so we had a chat room question from Vicky. Zilla, can you read that one?
Yep, Veggie Vicky asks us, since we're lucky enough to have some Monsanto expertise, could we ask you to talk about whether or not glyphosate bioaccumulates in humans as well as its shelf life in water soil or in water-stroke soil?
So the question is, does glyphosate accumulate in humans?
I think that's what she's getting at.
That's what it seems to be.
Yeah, glyphosate is the chemical name for a group of herbicides that have been around since the early 1970s. It's a very common herbicide, and it's an extremely safe herbicide. There are residues that are found in food, and they do get into the human body, but they do not accumulate in the human body. The characteristics of glyphosate from the experts that I've talked to indicate to me that it's water soluble, and the extremely low levels that are found in food are well underneath the 50-fold, 1,000 times in some instances, or below levels of concern for glyphosate exposure. So it is true, yes, glyphosate is found in food, and that it does get into our bodies, but it does not accumulate. People do not accumulate glyphosate. And the amounts that are found are so infinitesimally small that they are not a concern. In fact, despite all the debate, it's constantly undergoing recertification. And in the EU, the Germans who were responsible for redoing the recertification of glyphosate in this last round, and they've just come out with the conclusion that glyphosate is among the safest herbicides used in the world today.
Okay, who was? I can't remember the order the questions were in after that. There was another one coming. I think it was Zilla. Or
There was a follow up to that. Maybe we should take that.
Yeah, we'll take that one that just came in.
With glyphosate, can I also ask him to comment on the IARC's recent classification of glyphosate as a probable carcinogen?
Yeah, there's I've talked to a number of people in our organization about this, and the IARC is one of 4 agencies of the World Health Organization who evaluates different chemistries. 3 others have also evaluated glyphosate and said that it's of no concern. The IARC looks at the possibility of this, and they came up with a different conclusion. They don't look extensively at different studies. They looked at a small number of studies. We disagree with the classification that came out by the IARC. We don't believe it's been adequate or takes into account all the research that's been done, but it's a difference of opinion between us and the IARC. As I said, there are other agencies within the WHO that have no problem with glyphosate. And in fact, it's classified as a herbicide, which is a Category E herbicide in the US by the EPA, which means that it is evidence that it is not a carcinogen. So the question ends up being, okay, there's debate about it. Let's go to a third party. Let's get some studies done. Let's resolve that. But up until now, and this has been over the last 35 years or so, glyphosate has always had a clean bill of health.
Okay, well, Kitch, we know you had a store of questions and you haven't spoken much, so we'll let you come in here.
Yeah, I was just trying to figure out what's been said and what hasn't been said. Just on BT itself, I know that there's a number of different BT products, or the BT genes, CRY-A, CRY-B, and all those. Are they from the same bacterial strain, or are they, as in these are just different proteins that the bacteria produce, or are they from a variety of BT strains? And has any of these bacterial toxins been altered by protein engineering to improve their efficiency?
The answer to your question is yes, yes, sometimes, and yes. The first isolation, for a long time, there were thought to be a relatively narrow group of CRY proteins or BT proteins. And they were the CRY-A group, and then they expanded it to a total of 14 different serotypes of BT that produced different kinds of proteins. Early on, it was appreciated that there was a BT that produced a protein that was active against dipterans or mosquitoes. It was called the mosquito factor. There was another group of proteins that were only active on the lepidopterans. As time has gone on and our ability to sequence bacteria and genes, we've come to appreciate the world of BTs as being relatively rich in diversity, with lots of different kinds of BT proteins with activities on a number of different classes of insects. Now, at first, all we used was those basic classes. Then we started making chimera proteins, which had pieces of different ones to increase or improve the activity or expand the activity among a particular class. So even among a CRY-1AEC protein, for example, has very good activity against cotton bollworm, but poor activity against army fallworm. So we figured out which BTs are good on fallworm, which ones are good on earworm, and made kind of a chimeric that improved their activity. Since then, we're now looking at even more sophisticated ways of doing that engineering. And it's a good thing. It is very similar to what you see in the antibiotic industry of pharmaceuticals. So they came out with the basic beta-lactam antibiotics like penicillin and basic ones, and then they found modifications and changes which help keep the antibiotics ahead of resistance development. We're at a similar point, except that we have all the knowledge and information that has been developed over decades in the pharmaceutical industry. And we have the advantage that we're trying to be good stewards to the technology to minimize the development of resistance. For all those reasons, it is a really interesting characteristic of the industry, that we have the ability to make improved proteins with improved activity. As I'd said before, that just because they came from natural sources and they were put together, that doesn't change our obligation to continue to test and make sure that they retain the characteristics which made them so desirable to begin with. That is, their specificity and their potency of activity and their lack of activity on non-intended targets. So the answer is yes, but it is a triumph in modern science for how sophisticated we can be. And I'm quite optimistic about that. It'll help us for a long time.
And do you know about under resistance? Do you know? I know for antibiotics, there's various strategies out there to try to combat the emergence of resistance. Is there any strategies that exist to prevent the emergence of Bt resistance in the agricultural sector?
Yes, there are. Before we launched our product, Bt cotton product here in the United States and Bt corn, we consulted the best entomologists that we could find, and we had some very skilled ones here, both in the United States and Australia, Europe, but primarily the United States and Australia, and got their opinions and came up with a program of what's called Graphusia. So in this system, a farmer buys Bt cottonseed, for example, and he can plant 80% of his farm to Bt cotton, but keeps 20% out of Bt cotton. In that 20%, you can treat with traditional insecticides, but it provides a refuge, an area where the insects can survive without the presence of selection. So then when they cross with the selected ones on your Bt field, you don't amplify up the resistance, you actually dilute the resistance. And although complicated, this strategy has held off resistance extremely well here in the United States. And in fact, in Arizona, where they have some very strong practitioners of this, and it is a condition of our registration here in the United States to practice this strategy. They've held off resistance in Arizona for the last 20 years, and it's maintained the value of Bt cotton in Arizona, which is quite noteworthy.
And just on the just relating it back to antibiotic resistance, when that emerges, I know the virulence of the bacteria usually decreases. When resistance emerges in insects, does that affect the insects in any way? Compared to the wild type? Or?
It depends on the insect. From many of the experts I've talked to, there is a fitness cost associated with it. So a fitness cost associated with the maintaining the resistance. And in the absence of selection, the resistance pressure goes down. In other words, the example I gave earlier about whiteflies in Arizona, when there was resistance of whiteflies to pyrethroids did generate, it was a fitness cost. So if you stop spraying the pyrethroids, the number of resistant whiteflies goes down dramatically. It is a function of the insect itself. Some insects have it, some don't, and it's a case-by-case basis.
And
okay, we should probably take the caller.
Yeah,
now.
he's been waiting quite patiently. Kitch, we'll go to you after this, so that's all right.
Yeah, that's grand. Yeah.
Caller, Waltz, are you there?
Good afternoon.
Yeah, good evening. How you doing?
Evening.
Well, whatever. Yeah, you're on with Dr. Perlak. So, what's your question?
I have only had experience with genetic engineering using agrobacterium, and I wonder if there are any better methods used now, because it has only possibility of random insertion. So maybe there are newer methods which can insert DNA in the precise spot, not just randomly.
That's a good question, and the answer is yes, there are improved methods. Agrobacterium is somewhat random. I mean, it does have some basis homology for where it inserts, although it is such a low level of homology, it appears to be somewhat random. The advantage of being able to generate large numbers of plants is that you can then select the ones where you're very happy with where the insertion took place. So, for example, a standard of satisfaction is that we get insertion of our gene from the borders of Agrobacterium, and that when it inserts, we don't have any deletions or insertions, and that it's not in a coding sequence, it's not in a regulatory sequence, it doesn't appear to disrupt any other promoter or have any read-through sequences. We can be very selective on that end. Now, there are new technologies like the DNA editing and the CRISPR technology, which have the ability to knock out traits and to be able to alter genes within the chromosome. Those are very valuable technologies, and the potential is only beginning to be understood. I think that's the next generation of what's going to be really cool part of science. None of this stays stagnant. None of it stays the same. This is always changing, always improving. And there are new and better ways to do this. And I'm sure 10 years from now, someone will look at what we did and say, boy, was that dated. And it'll be true.
Okay, do you have anything else, Waltz?
No, I don't have anything else. Thank you.
All right, thank you very much for the
Thanks.
call.
Thanks for calling in.
Have a good evening. Okay, Kitch, we'll go back to your questions there.
Sure. I was going to ask: is there any research at the moment looking at other toxins from other bacteria?
You know, it's been a rich field for a long period of time. People have looked at toxins from Phytorhabdus. There's a number of other toxins that have specificity for insects or other pests. None of them seems to have the specificity or the potency that Bt toxins have. They found other proteins that do have some activity, but I don't know of any that have made it commercial just yet. And some of these proteins, well, a good example is using things like RNAi or RNA inhibition or suppression or whatever. We have a new possible product coming out for corn rootworm control that targets a specific gene in the corn rootworm. The advantage of that is you can kill the insect by disrupting a process that is unique to the insect. That is very laser-like focus. And it doesn't require a Bt gene to do that. That is really cool stuff. That's cool science.
Okay, anything else? Carry on.
Sorry, that's very interesting. How do they get the RNAi into the cells? Like how is it just taken by endocytosis, or is there a delivery mechanism involved?
In this particular case, it's introduced as a sequence through agrobacterium transformation. Now, people have been looking at, can the organism take up RNA directly, and could you use it as a a prep over plants, and there's different success levels associated with that. It's still so new and so early that I could tell you something and it might prove to be wrong tomorrow. But it is a very interesting area of research. But in this particular case, it goes in with a coding sequence that produces an RNA that is inhibitory to the specific insect, and it'll be inherited in the plant as part of the regular genetic makeup of the plant.
But how does the insect take it up, or?
When the insect eats it, in this particular case, the corn rootworm, when it eats the corn root, the RNA actually goes from, it is not disrupted in the gut of the insect. The RNA actually gets into the gut and is somehow transported and kills the insect. By the way, that is one of the limitations. Some insects do it and some insects don't. Some insects just won't take any RNA out. Some will take lots.
Okay.
Is that to do with the acidity of the gut, or?
There's a whole number of different factors: proteases, nucleases, acidity, pH. It's pretty complicated.
So basically, it's magic.
Now, Pumpkin, don't be saying that. People will think that it's just random. It's very precise. This is what this is hard work. I mean, that's what I always tell people. This is such hard work, and it is a marvel that we get this stuff done. I'm just amazed. No one would have ever, if you'd have told me at the beginning of my career I'd be talking to you about this level of sophistication, I'd have never said that were possible.
Okay, we do have another chat room question, so Ziller, take it away.
Yeah, this one it's again from Bored to Bits. Bored, why are you still here? You're meant to be making me a video. Does Dr. Fred think that GMO-derived products does Dr. Fred think that GMO-derived products should be identified as such? Yes or no, and why?
My answer is no, because of the way the laws are structured for labeling that I'm most familiar with in the United States. So in the United States, when you look at the label on the back of a package of food, it talks about the nutritional capability of the food, what it has, how much fiber, protein, carbohydrate. It is not about the process for how it was grown or where it was grown or what the genetic capability was. It is about the product. And under that scenario, if that is the way things are labeled, then GMO products should not be labeled as long as the products they produce are indistinguishable from ones grown without GMOs. Now, I can give you a case where we have a product called Vistiv oil, which is by genetic manipulation, we change the oil makeup of soybeans. We eliminate the polyunsaturated fatty acids from soybeans or reduce them so that hydrogenation is no longer required. So trans fats are no longer produced. We produce actually what's called a higher oleic oil in these soybeans. Those particular soybeans should be labeled as high oleic soybeans because they are different. They are different because they have been genetically engineered. They should be labeled. Something that isn't different shouldn't be labeled. Now, if people want to change the labeling laws and how labels are made and what they mean, then fine. Change the laws, and then you should maybe label them or not label them. But if you're going to do that for GMOs, then where does it stop? Well, I want to know what state it was grown in. I want to know what herbicides it was used. And if it's GMO or non-GMO, was it insect or herbicide or fungal resistance or nematode resistance or virus resistance? And how are people going to make heads or tails of that?
Also,
As long as they have the rules that are just about the product, then I'd say no.
So basically, otherwise we'll end up with buying a packet of food and a manual that's as big as an encyclopedia to go along with it.
Well, there are rules to this game, and we all play by the rules. And if they want to change the rules, okay, fine. But it has to be information that's useful to the consumer. So I can show you a bottle of corn oil from a non-GMO corn crop and a bottle of corn oil from a GMO corn crop, and they are completely indistinguishable. There is no chemical test, no process you can utilize to tell one from the other, because there is no DNA, no protein in that oil. It's a chemically defined substance. As a consequence, there are no differences. So what does the label tell you? It tells you absolutely nothing.
I have another question which slightly relates to that. Many people would say that a big deal with food is basically GMO versus organic. Do you think that there should be a slight difference in names, considering that all food has underwent some form of genetic modification? Take, for example, bananas, which used to be pure seed, and the fact that organic food is just that, except it hasn't been done in a lab.
Well,
A change to either one.
yeah. First off, there is a difference between traditional breeding and genetic engineering, as what it's commonly called, because it's transgenic. In other words, BT corn could only happen if we intervene. Now, there is some evidence. Jonathan Jones from the Sainsbury Center published a paper that talked about researchers have found that sweet potatoes have been engineered inadvertently by agrobacterium millennia ago, decades, centuries, however long ago it took. So those are natural processes. But when you talk about something like BT corn, it's clearly different from traditional breeding. By the same token, they do use chemicals on organic foods. They do use chemicals on organic crops, but it's a specific list of chemicals. Things like copper sulfate, the BT organism is okay to use on organic crops. Pyrethrum, which is the natural extract from the chrysanthemums that gave rise to pyrethroids, a chemical analog. Those are acceptable under organic venues, but pyrethroid, which would be the chemical analog of it, would be unacceptable. I think there's a lot of room for coexistence between organic and traditional and biotech research. I think that's fine. Every farmer I know would prefer to be as organic as they possibly can. Inputs cost him money, whether it's fertilizer or pesticides or herbicides, and he's got to be profitable to make it to the next level. So he's trying to maximize all the value he can. If he didn't have to use those inputs on his farm, he wouldn't. But I do think, I grow herbs in my backyard organically because I'm too lazy to put fertilizer, and I get more than enough, so I don't have to. Not many things eat basil. It's okay.
And it smells awesome.
Yeah. I think, like I say, we're coming up to the end of the show, so I want to play a little bit of devil's advocate. There's one, the reaction you must get from when you meet strangers that you work for Monsanto. I mean, how do you respond to that? Because there are people who just, like we said before the show, they just look at you as if you do have horns growing out of your head when you mention the M word, so to speak.
Yeah, I've worked long enough and hard enough on this that I sometimes say, okay, tell me what it is you don't like. And then someone would say, well, I don't like your company, but you're okay. Okay, that's fine. What I remind people of is that companies are about balance sheets. They're about profit and loss statements. They don't carry the visions, the hopes, the dreams of people improving agriculture. The people I work with, we feel passionately. We love agriculture. we really want to make it better. We're the ones who carry the dreams of all these new projects. And if our company makes money, and they should make money, and if that allows us to do more, to improve agriculture even more, hey, that's a good deal. So I have a lot of respect for Monsanto. I've had a great career there, and it is a point of pride for me because I'm so proud of the things that we do. Someone doesn't agree with it, that's fine. You know, you can't please everybody, but I have a lot of pride in what it is I've done. I know what I've done. I know what we've done as a company, and I don't have anything to hide about that.
Yeah, because it was just quite funny because the reaction even from some of our very loyal viewers when we announced a Monsanto employee, there was some saying, he seems all right, but he's Monsanto, so I'm not going to listen to him, which was, it saddened me quite a lot. You know, just,
Yeah.
you know, not to even just listen.
And this is a question I have for you guys. I mean, we're trying to be more open, to be more transparent. We're getting it. 5, 6, 10 years ago, if I'd have tried to have this conversation, nobody would want to listen.
Yeah.
Nobody cared. We've had GMO, we've had BT corn, BT cotton for 20 years. I tried to engage people in conversations, nothing. With the start of things like the internet, podcasts, all of a sudden everybody's interested. We were slow to respond, but we're here now. What should we do now to engage people to get them over that hump of how do we improve agriculture in the future?
Education. People don't understand what it is you do. They hear genetic modification and they get their information about that from Marvel Comics. So they think, what you're trying to create supervillains with the 3 eyes or whatever, and add to that it's big business. Yeah. And I mean, let's face it, I hate to insult the guest here, but big companies tend to be assholes. It's just that simple. They wouldn't be big companies otherwise. So I think it's sort of
Marty,
a combination of a lot of things.
I have to agree with the perception you talk about. I'm still explaining X-Files, the movie, that no, you can't engineer pollen to carry a virus and infect the entire world with something alien. I've had people who accept that as fact. And big companies, there's a lot of suspicion. And, are there things that we as Monsanto does that I wish we were better at? Yeah. Am I proud to work at Monsanto? You bet. Do I see us being different from other big companies? We do some things I am so proud of, so proud that we're involved in, and I wish we were better. I'm always trying to be more demanding of our management to do more, but that doesn't degrade the fact that we're pretty darn good where we are. Yeah. There's a lot of stuff that goes into it. And I'm suspicious of big companies. I've told a number of people this. I still don't know why when I go to the gas station, the price of gas is what it is. It doesn't seem to have any bearing on the price of crude. There's a refinery in California that's having a problem. Well, I live 2,000 miles away. What does that have to do with me? Yeah. I get it, but we're doing pretty good, and agriculture is getting better every day. That's one of the most encouraging things I've seen in my career.
I think I'm about to have a horrible moment where I come off as less of a bastard than Marty. Honestly, well, I would say Marty has it right with the education. I think you could dump spreadsheets for weeks and it won't make much of a dent in the diehard simpletons who just want to hate it for the sake of hating it. I think the best way to do it is by doing stuff like this, by having open, honest discussions with people like us who are curious.
Yeah.
it's easy to hate a big company. It's next to impossible to actually hate every person who works at it. It's basically you're a decent person, and I guarantee you that there's at least been one or two minds in the chat that have changed because of the conversations we've been having. So,
well, I'll give you a couple of sites that you can go to if you want to know more information. If people would like to contact me directly, they can get me at Fred Perlak on Twitter. And if they want to know more about Monsanto, they can go to discover.monsanto.com. If they have general questions about GMOs, there's a website called gmoanswers.com that will answer any question they have. Now, you might not like the answer, you might not agree with the answer, but at least you'll get an answer, and it's not just from Monsanto people, staffed by people from universities and other companies, organizations that can give you the kind of balance or a different view from what you might ordinarily see. So those three sites, but contact me. If you guys have a question, that somebody has a question that's just really, they can't figure out and they want to know what my take would be on it, at Fred Perlak on Twitter.
Okay, I'll just go around the team for final question. I see Marty doesn't have one, so Kitch,
you just answered my last
all right.
one.
So Kitch, a quick final question for Fred.
Could you come back to me? I'm just want to come up with something.
All right, Zilla. Zilla, please answer, Zilla. Yeah, there you are.
Yeah, I just had a couple of questions. I have to see the first one first, and if there is time for the second, I'll ask that.
Yeah.
Firstly, obviously in the 1990s in Europe, especially in the UK, we had quite a big anti-GMO thing going on. People going in, stomping on, like physically stomping on the product and the crops. I was wondering, what's the biggest kind of security concern you've faced since you've been working with Monsanto with your work?
Those sorts of things cross my mind, the attack of field research. I think in Great Britain you had the added anxiety over mad cow disease, where there was a distrust of regulatory agencies and the ability to protect individuals. Mad cow disease was such a horrible incident because it seemed to be so random. It seemed to be no rhyme or reason for who it hit or how it acted or why it did, and it came out of the blue. In terms of my own work, I've never really had issues with security of personal safety. I've had threats, I've had death threats, I've had personal property threats. In one of the instances, we talked to the police and the police said, well, don't worry about him, he's crazy. I said, that's the problem, he's crazy. But overall, I haven't had really too much of an issue. We've been fairly well regulated, and I think people here understand that.
Okay, we're coming up for the last 5 minutes. There was someone trying to get in, but sadly we just don't have time, so we've got to really start wrapping up. So as always, I'll go around your team for the final thoughts. Pumpkin.
It's been definitely interesting and fairly enlightening to have the conversation, but one little thing I've wanted to ask is,
I think we can squeeze that.
Yeah, considering some of the dumb shit that's been said in the chat, what's the dumbest or most hilarious anti-GMO myth you've ever heard?
When I was in Hawaii, someone told me that that we don't grow coconuts near our corn plants because the corn pollen is genetically engineered and so strong it'll pollinate the coconut plants. I just said, I don't even know how to start to talk about that one. That's probably the most bizarre one I've heard. Another one I heard was that the corn pollen It will burn you if it gets on you because it's genetically engineered. And they said that that's why our workers bundled up so much. And our workers in Hawaii were mainly former sugarcane or pineapple workers, many of them Filipino, other groups of individuals. They would bundle up because they didn't want to have, they're 9 hours out in the sun. They didn't want to have to put on sunscreen because number one, it's expensive, and number two, you don't want to do it every day. So they bundle up quite a bit with long sleeve shirts and gloves and put other shirts over their head to protect themselves from the sun. Those people work hard. They're really good people. Those were the other ones. One person was saying that corn pollen was getting on their car and causing rust spots. That was another hilarious one.
Why next to the ocean? That's
yeah, it had nothing to do with that, of course.
If you do get some corn pollinated coconuts, can you send them my way so I can have some massive pieces of popcorn?
Yeah, the only problem is when you heat them, they just blow up.
I live in Northern Ireland. That's a common occurrence.
There you go.
Okay, Marty, your final thoughts.
Yeah, it's just been great to have you here. It has been really interesting, and I got some questions answered that I don't know a lot about this stuff, and so yeah, I thought it was very interesting.
Well, thank you so much. Thank you for your time.
Yeah.
I really appreciate it.
All right, Kitch, your final thoughts, please.
It's been very, 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 very interesting. And it was just a very interesting discussion, and thanks for taking the time to come on the podcast.
Okay.
No problem, Kitch. Thanks again.
Okay, and Zilla, your final thoughts.
Yeah, just thanks for coming on. There's so many questions and so little time as ever with something like this. But I really appreciate you coming on and answering a few of the questions that us in the chat room have put to you. That's been great.
Okay, and as always, we give our guest a little soapbox moment. So if people have any further questions for you, I know you mentioned it earlier, but just to mention it again for anyone who's not quite got in with a question tonight.
Yeah, they can contact me at Fred Perlak on Twitter, or they can get answers on gmoanswers.com, or if they have specific questions or information they want about Monsanto, it's discover.monsanto.com. Please ask. That's the only way we're going to get to the next level, is some sort of dialogue. So please ask.
Yeah, I think I can say for everyone, it's been an absolute pleasure having you on, Fred. It's been fantastic, been very informative. And chat room, if you can do your usual thumbs up for our guest, that'll be fantastic. Yep, the thumbs are going up already, so that's brilliant. We're back in, this show will be uploaded hopefully sometime tomorrow. It'll be instantly up on YouTube. The podcast where I edit out kind of all the gaps and technical glitches should be up. I do have guests at the moment, so I won't be able to get to editing until late tomorrow. So hopefully Monday evening we should have the audio up. But again, just to let you all know, we're back in 2 weeks. Our guest then is the BBC journalist John Sweeney. Zilla, you can give us a quick rundown of John Sweeney.
He's basically an incredible UK journalist, does a lot of work with the BBC, did a few panorama programs, recently went over to North Korea not very long ago, did an expose of the regime there and life under the regime.
Yeah.
And he's probably most famous for his work on a couple of documentaries on Scientology, and uncovering the kind of underworld of Scientology, which made him very famous on YouTube as well.
Yeah. And yeah,
I've seen the guy has balls of bell steel.
Yeah, and also it's worth mentioning one of his earliest investigations, he actually managed to overturn some court rulings in the UK. There was 4 women who were convicted of killing their babies, but thanks to his work, they managed to overturn it. It was diagnosed as cot death, so he's done some really incredible work. And
yeah, he's one of the greatest investigative journalists of his time.
Yep. And so just to let you all know, the show will start quite early that day because we're starting at 5 p.m. We've been given permission to screen some of his programs. So if you tune in at 5, you'll get to see the programs, and then we'll be on with them, and you can all, there'll be like a question and answer session after seeing his programs. But again, that's what we've got coming forward. And again, a huge thanks to Dr. Perlak. It has really been great. And like I said, I don't think I can add anything more to that. But thank you, everyone, and enjoy your weekend wherever you are. Please take care till the next time.
Bye.
Cheers.
Bye, everyone.
Get drunk and have fun.
Thanks, fellas. For it, you actually got a halo effect where other pests were more efficiently controlled by natural mechanisms.
So it's almost sort of like a chicken and egg situation.
It is.
Yeah, there's so many insects because there's so many crops. And
well, and if you're a farmer, there are certain treatments that you make. So on a big field, for example, a farmer might spray a pyrethroid, but he'll know he'll have to go back and spray 21, 28 days later for another pest that'll bloom as a consequence of that spray. The advantage of things like BT cotton as an example, is if it's skillfully used to integrate into a program, a farmer can then maximize the use of of beneficial insects in an integrated pest management system. It's a tool. Biotech is a tool, and if properly used, is very, very effective. But just because you can cut lumber doesn't mean you can build a house. You have to pay attention. You have to work at it. And if you're good farmers, do well with these kinds of situations.
So it's, if I'm understanding it right, it's basically using BT. Is it BT resistant or BT infused?
It's BT infused. We actually produce the protein that used to be produced or still produced in the bacteria, but we take that gene out and we put it specifically into the plant so it produces it throughout the plant.
Right.
So that when the insect shows up, it's as if you had sprayed it with BT right when he gets there.
So it's by using the BT infused plants, it's reducing pesticides. So it's sort of a more efficient method of pest control rather than try to solve one, having to solve another. So it's
that's correct. The pesticides that traditionally are used, organophosphates, pyrethroids, carbamates, these classes of pesticides are fairly nonspecific, whereas the BT protein is highly specific. It's specific against these lepidopteran insects. Doesn't affect earthworms, doesn't affect honeybees, doesn't affect other pests like whiteflies.
Okay, and I think all right, good evening, everyone. Welcome to Trolling World Logic for the 29th of August, 2015. And we're here 7 p.m. here, UK time, 2 p.m. Eastern Standard Time over stateside. Just to let everyone know, you can call in in the show later on. The Skype contact, as you see, is the bottom of your screen, is Trolling World Logic. So just add us on Skype. I'll send a few PMs just to check what the topic of your question is, and we'll add you in due course. Just please do not call us. It just distract us during the interview or the show. And so we'll just quickly introduce the panel tonight and welcome you back. Pumpkin, what's happening?
Not much. Home from work, looking forward to going out and getting drunk, but in the meantime, I'll settle for this.
And welcome you back, Marty. How's it going?
Yeah, I'm doing fine.
And Zilla, what's up?
All good, all good.
Okay, everyone. Kitch was meant to be here, and he did have a nice introduction written for our guest. So I am just going to have to come up with hopefully something workable on the fly. Welcoming to the show is a well-known biotechnologist. He was involved in understanding expressions of BT genes within cotton, and I can't remember your exact role, but I'll say that you do work within Monsanto. So everyone, please welcome to the show, Dr. Fred Perlak.
Thank you very much for having me, Cal. It's a pleasure to be here.
Oh, it's great to have you. And so I think we'll just get on with a few basic questions just to get your background and all that. So what got you interested in biotech?
Well, I had a bachelor's degree in science from Fairfield University in Connecticut. And I did a senior project working in microbiology as a senior project, and I found that I really enjoyed working in the laboratory more than anything else that I could do. Went to graduate school, worked on Bacillus thuringiensis and its genetics as a graduate student. Found I had an aptitude for doing research. It was easy for me. Time went by very quickly, and from there I did a postdoc at the Ohio State University in Columbus, Ohio, and then from there to Monsanto. When I started at Monsanto in 1981, my job was basically to identify how we could take advances in recombinant DNA, genetic engineering, and apply them to improve agriculture. And so the obvious choice was to move Bt genes both into other bacteria that colonize plants and eventually put Bt genes into plants.
Okay,
and for those of us who are not sciencing regarding squishy stuff, what's a Bt gene?
Bt stands for Bacillus thuringiensis. It's a microorganism found in the soil. It has the unusual characteristic of producing a protein as a distinct crystal inside the cell. That particular protein has very high toxicity to a certain class of damaging insect pests, the lepidopteran insects. Those are the insects that are the larval forms of certain moths that are particularly devastating to crops. Corn earworm, tomato fruit worm, cotton bollworm. If you see a worm on a tomato or ear of corn or even on vegetable crops like lettuce or cabbage, it's probably that group of insects. And Bacillus thuringiensis, the protein produced, is extremely active. In fact, for years in the 50s and 60s, farmers have been can utilize microbial preparations of Bacillus thuringiensis sprayed over their fields to protect them from damage by insects.
Okay. All right. So Zilla or Pumpkin, do you have anything to come in with right now?
One little question is, I've always been curious about insect repellent GMOs, and the same could be said of pesticides, but I've always been curious. The fact that insects can't really eat them, does that cause any kind of damage to the food chain with, less food for something one step above insects not being able to get it and causing a knock-on effect? Does that ever become an issue, or?
That's a real good question, Pumpkin. I have to tell you, it's very difficult for me to call you Pumpkin, but that's another story.
Call me angry. Everyone does.
Okay, angry, that's good. Because one of the things we have to assess when we look at plants that are genetically engineered is what effect will they have on the environment? How will they affect things that happen? In the case of Bt plants, the insects that are eating the plants are described as pests already. There's nothing natural about the fact that you have a large number of acreage of those particular plants, and the insects get to very, very high, unusually inflated numbers because it's such a fertile area for them for having food that they can use. So it really isn't as disruptive as you might think. There is a ecological balance that you find in a field that can get changed or established. So for example, in the United States and Arizona, they had problems with an insect called the pink bollworm, and they also had problems with whiteflies. The way it worked was they would spray over and over with pyrethroids to try to control the pink bollworm. As a consequence, they were killing the whiteflies, but eventually the whiteflies were becoming resistant, and every time you sprayed with pyrethroids, more and more resistant whiteflies would show up. As a consequence of using all those insecticides, you actually caused a bloom of the secondary pests because you were killing all the predators of the whiteflies more efficiently than you were killing the whiteflies. Once Bt cotton was introduced, we controlled the pink bollworm. When the pink bollworm was controlled, they no longer sprayed the pyrethroids. When they no longer sprayed the pyrethroids, the natural predators took over and controlled the whiteflies to a manageable level in the field. So by eliminating one of the biggest problems in having to spray constantly, or aphids or thrips, but it takes out the biggest issue a farmer might have in his field, which allows him to be more selective and more judicious on how he treats those other insects.
Yeah, and that's actually answered another one of my questions when you said it doesn't affect bees, because I was going to ask if it would have any kind of effect with bees wanting to take the nectar and pollinate other plants, but
now, the beauty of Bt, there's two really highly desirable characteristics about this protein. First and foremost, it has a high degree of toxicity against the target host, among the most potent proteins for the insect toxicity. Secondly, it's extremely specific. Think of the Bt protein as a key, and the insect has a lock. The key fits very precisely into the lock, and only the insects that have the right lock does the key fit. And that's the lepidopteran insects. Other insects, other organisms, like even invertebrates, earthworms, other insects found in the soil, humans, animals, they don't have the right lock, so the key doesn't fit, so it doesn't work. It's one of the marvels of nature.
Okay, I'm sorry for butting in here. We have a guy in the chat room, and he's bringing up some. It's probably an anti-GMO guy, but he does bring up something interesting. I want to hear what you have to say about it.
Sure.
You have to buy seeds every year, presumably, if you're planting the genetically modified stuff. You have to buy seeds every year, as they don't reproduce like natural seeds do.
Can I?
I think he's basically hinting that it's a way to get farmers to cough up money or something.
If I would be able to say,
yes.
I live in a farming background, you always have to buy seeds every year, because you're never going to have enough seeds from the previous crop, because you're harvesting the seeds with the plant. So,
yeah.
Well, there's two parts.